In previous lessons, we learned how to factor trinomials. This is an example of a special product. Now, we still want to factor this the same way we've done in the past. We're going to look for it to be the product of two binomials. The first term is x squared, so we're going to write x and x as the first number in each binomial. But we're going to notice that 9 is also a perfect square. 3 times 3. If you recognize that both x squared and 9 are perfect squares, that's the first step to recognizing the special products. Now, of course, the second step is the middle term, that 6x, actually has to make sense. And in this case, if it's x plus 3 and x plus 3, it will. We can check that by doing FOIL very quickly. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And in this case, the 3x plus 3x will give you the 6x. Now, this is an example of a problem that if you recognize it, you can really try to avoid doing a lot of extra work. We're going to try another example. Like the first example, we have a trinomial. Now, the very first thing I want you to notice is that we have a perfect square at the beginning and at the end, which should lead you to believe, just like the last example, that this is the sum of two squares. In this case, x and x, and 5 and 5. In this case, however, we have a negative on the middle term. And you have to ask yourself, where does that negative come from and where does it go? And in this case, since we know 25 is a perfect square, it's a positive 25, the only way to get a positive is a positive times a positive or a negative times a negative. And in this case, it has to be a negative times a negative, because a negative 5 and a negative 5 will add up to negative 10. Now, one other bit of advice on a problem like this, you can actually write the answer as one binomial to the second power. Now, either answer is equally valid, but writing it as a square is just a shorter way of expressing the same information. It just takes less time. Now, our next example is another special products. In this particular case, it's very unique because it's not actually a trinomial. Everything else we've looked at has been. This is a binomial, but it's a special case. It's a perfect square minus another perfect square. And that means that just like the other work that we've done, it is actually the product of two binomials. In this case, x and 7 and 7. Now, the first question you should ask is, what happens to that middle term? Why is this a binomial instead of a trinomial? Well, it's actually a pretty easy solution. It turns out that the first parenthesis is x plus 7, and the second has to be x minus 7. And we'll check this doing FOIL. X times x is x squared. X times negative 7 is negative 7x. 7 times x is 7x. And positive 7 times negative 7 is negative 49. And what happens here is the two terms inside are the same coefficient but opposite signs, and they'll just cancel out. And all that's left is the x squared minus 49. This is called the difference of two squares. It only works for subtraction. Please be careful with that. It only works for subtraction. As long as you recognize the perfect squares, this is a fairly easy problem to factor.